Imagine for a moment a night sky fundamentally different from the one we know. Not just a sprinkle of stars or the occasional meteor shower, but two distinct celestial bodies, each with its own rhythm and glow, gracing the vast cosmic canvas above us. This is not a fleeting comet or a distant planet, but a constant dual presence, a pair of moons orbiting Earth. One, perhaps, is much like our familiar solitary companion, a large, luminous orb casting sharp, silvery shadows across the landscape. The other, a smaller, quieter companion, hanging farther out in the celestial sphere, a distinct, luminous disk, perhaps a different hue, moving with its own stately grace. Envision the twilight hours as the sun dips below the horizon, painting the clouds in fiery oranges and deep purples. Then, as the last vestiges of daylight fade, the first moon emerges, a brilliant pearl against the deepening indigo. Its light, a familiar, comforting silver, begins to wash over the land, picking out the contours of mountains, shimmering on the surface of oceans, and causing the distant tree line to appear as a dark, intricate silhouette. But then, as your gaze drifts, another light catches your eye. Higher, or perhaps off to one side, a second, smaller disk becomes visible. This companion moon, let us call it Luna Minor, might glow with a softer, perhaps golden, or even slightly bluish light, a subtle contrast to the stark brilliance of our familiar Luna Major. Its illumination would be gentler, casting diffused, almost ethereal shadows that intertwine with the sharper, more defined ones cast by its larger sibling. The visual experience would be profoundly transformative. On a clear night, when both moons are full or near full, the Earth would be bathed in an unprecedented level of natural light. Forests would appear in intricate detail, their leaves shimmering under the combined lunar glow. Rivers and lakes would become vast mirrors, reflecting not one but two celestial beacons, their overlapping reflections creating mesmerizing patterns on the water's surface. The shadows themselves would tell a complex story, with two distinct sets of projections, each moving at its own pace, stretching and shrinking as the moons traverse the sky. Imagine a lone tree casting a long, slender shadow to the west from Luna Major, and a shorter, broader, perhaps slightly offset shadow to the north from Luna Minor. The interplay of these shadows, constantly shifting, elongating, and overlapping, would turn every landscape into a dynamic, living artwork, a silent ballet performed by light and shade. The movements of these two moons would be a spectacle of continuous change. Our current moon takes roughly 27 days to complete one orbit around Earth, leading to its familiar cycle of phases. A second moon, especially if it were farther out as we are imagining, would likely have a longer orbital period. This means Luna Minor might appear to drift more slowly across the constellations, taking perhaps 40, 50, or even 60 days to complete its full cycle of phases. This difference in orbital speed would create an ever-changing celestial dance. Sometimes, the two moons might appear close together in the sky, a spectacular conjunction of twin lights. At other times, they might be on opposite sides of the celestial dome, one rising as the other sets, ensuring that at least one lunar presence is almost always visible after dusk. This independent motion would lead to a far more complex calendar of phases. While Luna Major cycles through its new crescent, quarter, gibbous, and full phases, Luna Minor would be doing the same, but out of sync. One night, you might see a brilliant full Luna Major accompanied by a slender crescent Luna Minor. Weeks later, Luna Major might be a barely visible sliver, while Luna Minor shines as a radiant full disk. The visual permutations would be endless, demanding a constant attentiveness from any observer. Early civilizations, gazing up at this double spectacle, would have been compelled to develop far more intricate systems for tracking time, marking seasons, and predicting celestial events. The very definition of a month would become a matter of debate, tied to the cycles of one moon or the other, or perhaps an attempt to harmonize both. The sensory experience of such a world extends beyond just sight. The increased ambient light from two moons could subtly alter the behavior of nocturnal animals. Some creatures, accustomed to the deep darkness of a single new moon, might find their hunting or foraging patterns disrupted by the more frequent and intense lunar illumination. Others might thrive in the prolonged twilight, extending their activity periods. The very air might feel different under the twin glow, a sensation of constant, soft vigilance rather than the profound mystery of a truly dark, moonless night. The sounds of the night, from the rustling of leaves to the distant call of an owl, would echo through a landscape perpetually half-lit, never truly succumbing to absolute darkness, save for the rare occasions when both moons are new or obscured by clouds. For humanity, the presence of two moons would have shaped our fundamental perception of the cosmos from our earliest days. Imagine our distant ancestors huddled around a fire gazing at not one but two glowing orbs. The single moon we know has inspired countless myths, legends, and scientific inquiries. Its steady presence has been a constant in our skies, a symbol of constancy and change, of beauty and mystery. But with two moons, the human imagination would have been stretched in entirely different directions. The heavens would not be a singular, predictable entity, but a dynamic, interacting system, a cosmic partnership. This duality would be ingrained in the very fabric of early thought, perhaps giving rise to notions of balance, opposition, or cosmic twins. The concept of a moonless night would be an exceedingly rare event, perhaps occurring only when both moons are in their new phase, or when their respective positions mean one is below the horizon while the other is new. Even then, the chances of both being new simultaneously would be statistically low, making truly dark nights a precious and perhaps even feared rarity. Conversely, the double full moon night would be a spectacle of unparalleled brilliance, a celebration of light that would transform the darkest corners of the world into an ethereal, almost daytime-like landscape. Such nights would undoubtedly become focal points for cultural rituals, festivals, and storytelling, occasions of profound significance etched into the collective memory of early human societies. This constant dual presence would also deeply influence the development of navigation. Sailors would have two distinct celestial markers, each with its own predictable yet intertwined path. The combined gravitational effects of two moons, as we will explore further, would create complex tidal patterns, but visually, their presence would offer a rich tapestry for celestial navigation. Ancient mariners, already adept at reading the stars, would become masters of lunar trajectories, perhaps even using the relative positions and phases of the two moons as a sophisticated celestial clock or compass. The very stars might seem to take a secondary role to the dominant, ever-changing drama unfolding between the twin celestial wanderers. The implications for our earliest understanding of the universe would be profound. The idea of a single central Earth with one orbiting companion is a relatively straightforward concept, but with two, the heavens immediately become more complex, hinting at a universe of interacting bodies, of gravitational dances and intricate mechanics. This might have spurred astronomical inquiry earlier and in different directions, prompting questions about orbital mechanics, relative distances, and the forces that bind celestial bodies together. The universe would present itself not as a solitary stage for humanity, but as a grand, intricate clockwork, revealing its gears and springs through the ceaseless motion of its twin lunar hands. The very sense of time would be different. Our single moon provides a consistent, if sometimes obscured, marker of the passage of days and weeks. With two moons, each with its own cycle, the experience of time would be layered and multifaceted. Some cultures might track time by the faster moon, others by the slower. Perhaps a grand double month would emerge, a period defined by the synchronization of both lunar cycles, a rare and auspicious event. This celestial complexity would permeate language, art, and philosophy, embedding the concept of duality, or perhaps even trinity if we consider the sun, into the very core of human thought. The sky would not merely be a backdrop, it would be an active participant, a dynamic character in the ongoing story of Earth and its inhabitants. This initial sensory experience, this constant visual and temporal reminder of two celestial bodies, would set the stage for everything else. It would be the fundamental difference, the single change that ripples through geology, biology, and culture. The dual embrace of the night sky would not just be a pretty sight. It would be the first, most immediate, and perhaps most profound alteration to our world, shaping the very way we perceive existence, the universe, and our place within it. It's a world where the familiar comfort of a single moon is replaced by a more complex, perhaps more awe-inspiring, and certainly more enigmatic celestial partnership, forever altering the canvas upon which life and civilization would unfold. The celestial ballet playing out in the night sky, a mesmerizing dance of two moons, would be far more than a visual spectacle. Its true impact would resonate deep within the very fabric of our planet, orchestrating a profound and continuous reshaping of Earth's physical environment. The elegant gravitational embrace of a solitary moon, which we know so well, gives way to a complex, often chaotic interplay when a second celestial body, Luna Minor, joins the cosmic waltz. To understand this transformation, we must first grasp the concept of gravity. Every object with mass exerts a gravitational pull on every other object with mass. The strength of this pull depends on the masses involved and the distance between them. Our own moon, Luna Major in this scenario, is Earth's primary sculptor of tides. Its gravitational force pulls at the Earth, but crucially, it pulls more strongly on the side of Earth facing it and less strongly on the far side. This differential pull stretches the Earth slightly, creating bulges of water on both the near and far sides, which we experience as high tides. As Earth rotates beneath these bulges, coastal areas experience two high tides and two low tides, roughly every 24 hours and 50 minutes. The sun also contributes to these tidal forces, creating the familiar spring tides, when sun and moon align for stronger pulls, and neap tides, when they pull at right angles, resulting in weaker tides. Now, introduce Luna Minor into this delicate balance. Even if smaller and farther away, its gravitational field would still be a significant player. Its pull would not simply add to Luna Major's, but would interact with it in a complex dynamic fashion. Imagine dropping two stones into a still pond at different times and locations. Their individual ripples spread out, but where they meet, they don't just sum up, they interfere, creating intricate patterns of amplification and cancellation. This analogy, though simplified, helps visualize the gravitational interference. The two moons, each orbiting Earth at its own speed and along its own path, would constantly shift their relative positions. Sometimes they would align, pulling in the same general direction, amplifying the tidal bulges to unprecedented heights. At other times, they would pull in opposing directions or at oblique angles, creating a far more intricate and unpredictable tidal landscape than we could ever imagine with just one moon. This dual gravitational tug would fundamentally rewrite the ocean's rhythm. The predictable semi-diurnal tides, with their steady ebb and flow, would become a relic of a simpler universe. Instead, coastal zones would experience a bewildering array of tidal patterns. A single day might witness not just two high tides, but 3, 4, or even more distinct peaks and troughs, each arriving at an irregular interval and reaching a wildly unpredictable height. One moment, the waterline might creep almost imperceptibly, lulling coastal organisms into a false sense of security. The next, a monstrous surge, a super spring tide born from the rare perfect alignment of both moons, could crash ashore, inundating areas typically untouched by the highest waters. Conversely, during periods of complex opposition, a super neap tide might leave vast stretches of the seabed exposed for extended periods, far beyond the normal low tide mark. The very concept of a tide table, as we know it, would be a mind-bending exercise in advanced celestial mechanics, requiring constant recalculation and possessing a far wider margin of error. The scale of these tidal fluctuations would be dramatic. While our current Bay of Fundy experiences tidal ranges of up to 16 meters, a world with two moons could see regular fluctuations exceeding 20 or even 30 meters in some constricted bays and estuaries. The sheer volume of water moving with such intensity would unleash unprecedented forces upon coastlines. The roar of the incoming tide would no longer be a gentle whisper, but a thundering crescendo, a constant reminder of the relentless power of the heavens. The soundscape of coastal regions would be dominated by the incessant, unpredictable slosh and surge of water. These chaotic tides, in turn, would profoundly reshape the global ocean currents. Tides are a significant driver of water movement, and with such unpredictable and powerful tidal forces, ocean currents would become a maelstrom of turbulence. Major currents like the Gulf Stream or the Kuroshio Current, which play crucial roles in global heat distribution, might find their paths altered, their speeds fluctuating wildly, or even their very existence challenged by the constant, irregular stirring from the two moons. Imagine vast, powerful eddies and whirlpools forming and dissipating with startling frequency, making sea travel treacherous and unpredictable. The deep ocean currents, part of the immense global conveyor belt, or thermohaline circulation, which transports heat and nutrients around the planet, would also be affected. This circulation is driven by differences in water density, influenced by temperature and salinity, but it is also subtly nudged by surface currents and tidal mixing. The constant, unpredictable stirring from the dual moons could either strengthen this conveyor belt, leading to more extreme heat transfers, or weaken it, plunging some regions into prolonged cold snaps, while others sweltered. Such shifts would have cascading effects on global climate patterns, potentially leading to more erratic weather, more frequent and intense storms, and unpredictable regional temperature swings. Nutrient upwelling zones, vital nurseries for marine life, would be subject to erratic forces, creating boom and bust cycles for ecosystems that rely on their steady supply of life-giving minerals from the deep. The relentless, unpredictable assault of these powerful tides would have dramatic consequences for Earth's geology, particularly its coastlines. Coastal erosion would be greatly accelerated. Cliffs, instead of gradually receding over centuries, might crumble at a faster pace, unable to withstand the varied and intense forces. Beaches, instead of forming stable, long-term features, would be in a state of constant flux, their sands and gravels relentlessly scoured, transported, and redeposited by the ever-changing currents. Vast, transient mudflats and sand shoals might emerge and disappear with each lunar cycle, making navigation and human settlement near the coast an immense challenge. Estuaries, the delicate transition zones between rivers and the sea, would be far wider, more dynamic, and subject to extreme salinity fluctuations, forcing unique adaptations from any life forms attempting to inhabit them. The geological record itself would bear witness to this tumultuous era, with sedimentary layers showing far more complex patterns of deposition and erosion, perhaps even fossilized evidence of these extreme tidal rhythmites. Beyond the oceans, the dual gravitational pull could even influence the very rotation of our planet. Our current moon exerts a tidal friction that gradually slows Earth's spin, lengthening our day by about 2.3 milliseconds per century. With two moons, the combined tidal friction would likely be significantly greater, accelerating the deceleration of Earth's rotation. This means that early Earth, with its two celestial companions, might have had even shorter days than our single moon past, and those days would have elongated much more rapidly over geological timescales. The precise rate of slowing would not be constant. It would fluctuate based on the relative positions and orbital resonances of the two moons. Imagine moments when their combined pull creates a powerful break, followed by periods when their forces partially cancel, offering a temporary reprieve. The long-term history of Earth's day length would be a fascinating non-linear curve, a testament to the intricate dance above. Furthermore, while highly speculative, some scientists propose that lunar gravity might exert a tiny, subtle influence on the Earth's internal processes, such as tectonic activity or volcanic eruptions, by inducing minute stresses within the solid Earth. With two moons, especially if one possessed a more eccentric or inclined orbit, these internal stresses could be amplified. The constant varying gravitational squeeze and stretch from the celestial pair might subtly knead the solid Earth, potentially influencing the movement of magma, increasing the frequency of minor earthquakes, or even triggering eruptions in already volatile volcanic regions. This wouldn't be a dramatic instantaneous effect, but a long-term subtle influence that could contribute to a slightly more geologically active planet. In essence, the silent ballet overhead translates into a furious, unpredictable dance on Earth's surface and deep within its core. The predictable clockwork of our familiar tides would give way to a complex, powerful symphony of water and rock. This profound interaction would not merely alter Earth's environment, it would fundamentally rewrite the rules for oceanography, reshape coastal geology, and even influence the very spin of our planet. This celestial partnership, unseen by human eyes for eons, would have forged a world of constant change and immense physical power, laying the groundwork for a truly unique biological and cultural tapestry. Imagine a world where the very cradle of life, the dynamic intertidal zone, was not merely a challenging environment, but a relentlessly chaotic one. If Earth had two moons, the intricate dance of lunar major and lunar minor would have subjected these coastal margins to an unprecedented regime of environmental stress, fundamentally altering the evolutionary trajectory of early life. The regular, predictable ebb and flow we know today, a rhythm that has guided countless species, would be replaced by an erratic ballet of water levels, where the ocean could surge far inland or recede dramatically, sometimes multiple times a day, with little warning. Consider the sensory landscape of such a primordial shore. The air would be thick with the scent of brine and exposed mud, continually churned by the restless waters. The soundscape would be dominated by the perpetual roar of waves, not a steady percussion, but an unpredictable symphony of crashes and surges as powerful superspring tides, driven by the combined gravities of both moons, battered the coast, followed by periods of extreme exposure. These intertidal zones, the areas between the high and low tide marks, would be vastly more extensive and volatile, stretching for kilometers in some places, constantly redefining the boundary between land and sea. This environment would not just select for the hardy, it would forge entirely new strategies for survival. The first forms of life to venture into these tumultuous waters would have faced an immediate and profound challenge: how to avoid being swept away, crushed, or dried out. Microorganisms, the pioneers of Earth's early ecosystems, would have had to develop extraordinary resilience. Imagine microbial mats, the ancient predecessors of complex life, not just clinging to rocks, but forming incredibly robust, almost cement-like biofilms, perhaps reinforced with mineral precipitates, to withstand the constant scouring of turbulent water and abrasive sediments. Their cell walls might be thicker, their internal chemistry more adept at regulating water content to survive prolonged exposure during extreme low tides, or sudden inundation during high tides. Dormancy, a state of reduced metabolic activity, might have become a far more common survival strategy, allowing these microscopic organisms to wait out the most brutal tidal cycles. As life progressed from simple single-celled organisms to more complex multicellular forms, the selective pressures would intensify. The intertidal zone, often seen as a transitional habitat, would become a crucible of rapid adaptation. Organisms here would need not just one or two survival mechanisms, but an entire toolkit of physiological and anatomical adaptations. Let's take a look at the early invertebrates, the ancestors of crabs, mollusks, and worms. For them, simply holding on would be a matter of life or death. We might see the evolution of incredibly powerful attachment mechanisms, limpets with suction stronger than any found today, mussels developing byssal threads that could anchor them to solid rock against hurricane-force water movement, or barnacles evolving carapaces fused so tightly to the substrate they become virtually inseparable. The constant physical stress would also drive the development of robust protective coverings. Think of shells becoming exceptionally thick, perhaps layered with additional shock-absorbing materials, or evolving complex interlocking patterns to resist crushing forces. Exoskeletons, the external skeletons of arthropods, might become denser and more articulated, allowing for both strength and flexibility in the face of relentless wave action. Burrowing organisms like early worms and clams would need to dig deeper and faster into the substrate, creating more stable retreats from both the pounding surf and the desiccating sun during prolonged low tides. The very act of movement and feeding would also be shaped by this chaotic environment. Filter feeders, like sponges or early bivalves, would need to process water that was often laden with sediment, requiring highly efficient filtration systems or the ability to periodically shut down and clear their feeding apparatus. The unpredictability of the dual moon tides would also profoundly impact reproductive strategies. On our single moon Earth, Many marine species synchronize their spawning with predictable lunar cycles, often around full or new moons, when tidal currents are optimal for dispersing larvae. In a world with 2 moons, such simple synchronization would be impossible. Reproductive cycles might become far more complex, perhaps tied to specific rarer alignments of both moons that offered a brief window of relative calm. Or they might become continuous, broadcasting gametes whenever conditions permitted, relying on sheer volume to ensure some survival. Larval stages would need to be exceptionally resilient, capable of surviving long periods in turbulent waters, or perhaps evolving to settle rapidly to avoid being swept into unsuitable habitats or deep ocean currents. Beyond the immediate intertidal zone, the chaotic tidal forces would ripple through the broader marine ecosystems. The increased mixing of ocean waters, driven by the powerful and erratic currents, would have a significant impact on nutrient distribution. While this turbulence could bring a constant supply of nutrients from the ocean depths to the surface, fueling bursts of productivity, it would also create an incredibly dynamic and stressful environment for plankton, the base of the marine food web. Organisms would need to be highly adaptable to fluctuating nutrient availability, temperature, and salinity. Upwelling zones, where cold, nutrient-rich deep water rises to the surface, might be more intense but less stable, leading to highly productive but geographically shifting marine hotspots. Estuaries, the brackish zones, where rivers meet the sea, would be particularly extreme environments. Here, organisms would have to cope not only with the chaotic tides, but also with wildly fluctuating salinity levels, as freshwater runoff battled against powerful saltwater intrusions. Plants and animals in these areas would require exceptional osmoregulation capabilities, the ability to maintain a stable internal salt balance despite external changes. We might see the evolution of incredibly robust coastal vegetation, like pioneering forms of salt marshes or mangrove-like forests, with deep, anchoring root systems and specialized glands to excrete excess salt, creating unique biological barriers against the relentless tidal assault. These plant communities would not only stabilize the shore, but also provide crucial refugia for other life forms. Over eons, these relentless selective pressures would have sculpted a biological tapestry on Earth profoundly different from our own. The concept of survival of the fittest would take on an even more brutal meaning in a dual-moon world, where adaptability and sheer resilience were paramount. Life would be constantly challenged to push the boundaries of physiological tolerance and structural integrity. The biodiversity might be skewed towards species capable of enduring extreme fluctuations, perhaps at the expense of highly specialized, delicate organisms that thrive in more stable environments. This constant environmental shaping would ensure that every species, from the smallest microbe to the largest marine predator, bore the indelible mark of the 2 moons, their very forms and functions a testament to the powerful gravitational ballet above. The world would be a place where life learned to dance with chaos, to thrive not despite the unpredictability, but often because of it. The relentless churning of the waters, the constant reshaping of the coastline, and the dynamic nutrient cycles would create opportunities for organisms that could rapidly colonize new areas or exploit transient bursts of resources. It would be a planet where the very definition of a stable ecosystem was constantly being rewritten by the celestial mechanics of its 2 luminous companions, leading to a unique and endlessly fascinating evolutionary story. Imagine a world where the night sky is not a solitary stage for a single luminous orb, but a grand theater where two celestial actors perform an eternal, intricate ballet. This profound visual difference would not merely be an aesthetic curiosity, it would pierce deep into the human psyche, fundamentally altering our earliest attempts to comprehend the cosmos and our place within it. From the very first stirrings of human consciousness, observing the shifting interplay of Luna Major, the familiar dominant moon, and Luna Minor, its smaller, quieter companion, would have imprinted a pervasive sense of duality onto the nascent minds of our ancestors. The constant presence of two distinct lights in the night, each with its own rhythm and personality, would have offered a rich tapestry of sensory input. Picture a twilight where the larger moon begins its ascent, casting long, familiar shadows, only to be joined later by the fainter glow of its sibling, painting the landscape with overlapping, complex patterns of light and shade. Sometimes they might appear close, a breathtaking conjunction, their combined brilliance turning night almost into day. At other times, they might be on opposite sides of the sky, pulling at the earth from different directions, their individual presences a constant dual reminder. This visual duality, ever present and inescapable, would have served as the ultimate canvas upon which humanity would project its earliest fears, hopes, and explanations for the universe. This immediate, visceral experience of a dual sky would have been the fertile ground for the emergence of profoundly dualistic mythologies. Instead of a singular moon goddess or god, early cultures would almost certainly have conceived of twin deities, reflecting the celestial pair above. Luna Major, with its brighter, more commanding presence and its powerful influence on the chaotic tides described earlier, might be personified as a potent, perhaps even temperamental mother figure, a bringer of life and sustenance, but also a force of destructive change and unpredictable power. Her cycles would dictate the major rhythms of life, the growth of crops, the abundance of the sea, the very pulse of the coastal world. Conversely, Luna Minor, appearing smaller, perhaps more distant and serene, might be seen as a quieter, more introspective sibling, perhaps a wise elder, a watchful guide, or even a mischievous trickster, whose subtle movements and fainter light offered hidden knowledge or less obvious influences. Its glow might be associated with dreams, secrets, or the unseen currents of fate. Imagine ancient stories where these twin deities are not just separate entities, but intertwined forces, locked in an eternal dance of cooperation and occasional conflict. One might represent the overt, the manifest, the conscious; the other, the hidden, the subtle, the unconscious. These twin celestial bodies would not just be characters in stories, they would embody foundational philosophical concepts that permeate all aspects of early human thought. The interplay of light and shadow, ebb and flow, creation and destruction would be intrinsically linked to the moon's movements. Human societies might have developed intricate cosmologies based on the idea of balance between two opposing yet complementary forces. Or, conversely, they might have seen the moons as perpetually locked in a struggle for dominance, reflecting and perhaps even dictating the conflicts and harmonies within human communities. This duality could be woven into the very fabric of their understanding of good and evil, order and chaos, masculine and feminine principles. The concept of two paths, or twin destinies, might become a recurring motif, deeply rooted in the celestial example. Consider the rituals and ceremonies that would evolve from such beliefs. Festivals would not merely celebrate a single full moon, but perhaps the rare, spectacular double full moon conjunction, a time of immense power and heightened spiritual significance. Or, conversely, rituals might be performed during the double new moon, the darkest nights, to honor the hidden aspects of the cosmos. Offerings might be made to one moon for abundance and to the other for protection or guidance. Shrines might feature twin altars, and sacred art would undoubtedly depict the two moons in various states of conjunction, opposition, or celestial embrace, each configuration carrying specific meaning and omens. The very architecture of early temples might orient itself not just to the sun, but to the intricate paths and alignments of both moons. Beyond the realm of myth and spirituality, the practical necessities of life would also compel humanity to grapple with the complex cycles of two moons. Our own single moon provides a relatively straightforward 29.5-day cycle, forming the basis of many early calendars, with two moons each possessing its own orbital period and phase cycle. The challenge of tracking time would be immensely more intricate. Imagine the frustration and ingenuity required for early hunter-gatherers or nascent agricultural societies to predict the best times for planting, harvesting, or migrating, when the tides and light levels were governed by two independent yet interacting celestial clocks. Early calendars would likely be bilunar, attempting to reconcile the rhythms of both bodies. Perhaps one moon, Lunar Major, would dictate the larger seasonal shifts due to its more dominant gravitational pull on the oceans, while Lunar Minor's cycle might mark shorter periods or be associated with specific phenomena like the spawning of certain fish species. The concept of a month might become far more fluid and complex, perhaps even having two distinct types of months simultaneously, or a larger cycle that encompasses the synodic periods of both moons before they realign. The development of early astronomical observation would be accelerated and intensified, as the need to accurately predict these complex celestial events would be paramount for survival and societal organization. Specialized individuals, perhaps early astronomer priests or moon seers, would dedicate their lives to charting the moon's intricate dance, their knowledge becoming a source of immense power and authority within their communities. Navigation, too, would be transformed. For ancient mariners, our single moon is a valuable, if sometimes elusive, guide. With two moons, the sky would offer a far richer, albeit more complicated navigational toolkit. Sailors could use the relative positions of Lunar Major and Lunar Minor to gauge direction, their combined light providing illumination even on nights when one moon was new. Specific conjunctions or oppositions of the two moons could serve as celestial landmarks, marking particular seasons, or even indicating cardinal directions with greater precision than a single moon could offer. The challenge, however, would lie in understanding the constantly changing geometry of their dance. A mariner would need to master not just the phases of one moon, but the interplay of two, predicting their visibility, their combined brightness, and their gravitational effects on the tides, which would be critical for coastal navigation. The intricate celestial mechanics of a dual moon system would demand a level of observational sophistication from early humans that might far exceed what was necessary on our single moon Earth. The very act of discerning patterns in the chaotic tidal surges and the irregular light cycles would hone cognitive abilities for pattern recognition and complex prediction. This constant intellectual challenge, driven by both practical necessity and spiritual wonder, would shape foundational human beliefs about order, predictability, and the power of observation. The universe would be perceived as a place of profound complexity, a cosmic mechanism that, while challenging, could be understood and even predicted by those astute enough to decipher its signs. This pervasive duality would seep into the very language and metaphors used by humanity. Instead of once in a blue moon, perhaps phrases like when the twins embrace or under the shadow of the lesser light would denote rare or significant events. Poetry would find endless inspiration in their combined beauty and mystery. The concept of a moonlit night would gain new layers of meaning, encompassing the varying interplay of two distinct glows. The dual moons would not just be objects in the sky, they would be ingrained symbols in the collective unconscious, shaping dreams, influencing art, and providing a constant, undeniable backdrop to all human experience. Their presence would foster a worldview where balance, interaction, and the dynamic interplay of forces are central to understanding existence, leading to a profoundly different cultural tapestry than the one woven under the solitary gaze of our single moon. The pervasive duality of a two-moon sky, once etched into the bedrock of myth and ritual, inevitably began to shape humanity's intellectual and creative endeavors. From the ancient observer gazing upward, trying to discern patterns in the celestial dance, to the philosopher pondering the very nature of existence, the double light became a profound lens through which the world was understood and expressed. It was an ever-present catalyst, urging a deeper, more intricate engagement with the cosmos than a solitary moon could ever inspire. Imagine the task of the earliest astronomers. Our own ancestors, with a single moon, developed remarkably accurate calendars and navigation methods by tracking its familiar phases and predictable path. But in a world graced by Lunar Major and Lunar Minor, the heavens presented a far more intricate, demanding puzzle. No longer was it a simple matter of observing one orb's steady progression across the ecliptic. Now, two distinct gravitational partners, each with its own orbital period, inclination, and phase cycle, wove a ceaseless, ever-shifting tapestry of light and shadow. The challenge was immense, predicting not just the position of one, but the synchronized and often perturbing dance of two celestial bodies. This complex interplay forced a profound evolution in human scientific and observational capabilities, pushing the boundaries of early mathematics and instrumentation. The need for precise prediction spurred an unprecedented drive for astronomical accuracy. Early skywatchers, initially relying on generations of oral tradition and etched stone markers, would quickly realize the inadequacy of simple observation. Instead, dedicated lunar academies might have emerged in ancient civilizations, centers of learning where scholars meticulously catalogued the movements of both Lunar Major and Lunar Minor. Imagine colossal observatories, perhaps more elaborate than Stonehenge, designed with multiple sighting lines and complex gnomons to track the distinct paths of both moons, recording their conjunctions, oppositions, and particularly the rare, spectacular double eclipses. The very act of charting these complex celestial mechanics would necessitate the invention of highly specialized instruments. Picture an early bilunar astrolabe, perhaps featuring two superimposed reed plates or a more intricate set of scales, allowing for simultaneous measurement of the altitudes and relative positions of both moons against the backdrop of the stars. The development of such tools would not only reflect, but also drive advancements in metallurgy, optics, and precision engineering far earlier than in our own timeline. This intricate dance in the sky also reshaped the fundamental tools of timekeeping, building upon the bilunar calendars discussed earlier. These systems would evolve into incredibly sophisticated instruments of daily life. Rather than merely tracking lunar months, societies would develop complex lunar epochs defined by specific, recurring alignments of both moons. A rare grand conjunction might mark the beginning of a new era, while a double opposition could signify a period of introspection or renewal. The very concept of a day or night might be subdivided not just by sun and moon, but by the waxing and waning of major and minor, their relative positions, and the unique patterns of their combined light. This immense chronological complexity would foster an early appreciation for abstract mathematical models and rigorous data analysis, laying groundwork for computational thinking. For mariners, the two moons presented both a profound challenge and an unparalleled opportunity for navigation, albeit one demanding extraordinary skill. While the chaotic tides of a two-moon world would make coastal navigation perilous, the open ocean offered a different kind of celestial compass. Determining latitude by the height of a single star or moon is a foundational skill, but determining longitude, especially before accurate chronometers, relied heavily on lunar observations. With two moons, the problem of longitude could be solved with greater precision, but also with far greater complexity. A navigator wouldn't just need to know the position of one moon relative to the stars, but both moons and their constantly changing relative positions to each other, all while accounting for Earth's rotation and the Sun's influence. This would demand incredibly precise instruments, perhaps a double moon sextant, capable of simultaneously measuring angles to both moons and a reference star. The data required would be immense, voluminous tables of ephemeroids for two bodies, accounting for their mutual gravitational perturbations, meticulously compiled over centuries. This would necessitate large, dedicated astronomical institutions and libraries of celestial data, making the skill of a master navigator a revered, almost priestly profession, requiring years of intense study and an intuitive grasp of complex celestial mechanics. Such a demanding environment might have delayed long-distance ocean voyages for millennia, or conversely, spurred the development of advanced navigational mathematics and tools at an accelerated pace, pushing humanity to master the seas through sheer intellectual force. The constant, observable gravitational interactions between Lunar Major and Lunar Minor would provide an unparalleled laboratory for understanding the universe's fundamental forces. The three-body problem, concerning the unpredictable motions of three mutually gravitating bodies, is notoriously complex. Yet, the stable, albeit intricate, dance of Earth and its two moons would present an observable, real-world manifestation of these complexities. Early natural philosophers, instead of waiting for a single brilliant mind like Isaac Newton, might collectively and incrementally develop sophisticated mathematical tools to describe these dynamic changes. Perhaps a proto-calculus or an advanced form of spherical trigonometry would emerge much earlier, driven by the practical necessity of predicting lunar movements for navigation and timekeeping. The constant intellectual challenge posed by the celestial ballet would foster a culture of precise observation, rigorous data collection, and abstract mathematical reasoning, potentially leading to a golden age of celestial mechanics millennia before our own. The visible perturbations of one moon by the other would offer tangible evidence of universal gravitation, perhaps allowing for its conceptualization with greater clarity and detail from the outset. This constant interplay of two celestial lights did not merely challenge the intellect, it ignited the human spirit, transforming the very canvas upon which art and literature were conceived. The visual aesthetic of a dual moon world would be profoundly unique. Imagine a landscape bathed in bilunar light, one moon might cast a sharp, cool silver, while the other provides a softer, warmer glow, creating entirely new palettes for artists. Paintings would feature scenes where shadows stretch in two different directions, converging or diverging depending on the moon's positions, symbolizing choice, consequence, or parallel realities. The double full moon night, a rare confluence of both orbs at their brightest, would be depicted with dramatic flair, an event of either apocalyptic portent or ecstatic wonder, depending on the cultural context. Architecture might evolve to incorporate twin spires or double arches, not just for aesthetics, but as symbolic representations of the celestial pair, designed to capture or frame the moon's distinct paths or interact with their complex shadow play. In poetry and literature, the two moons would serve as ultimate, ever-present metaphors. They would symbolize duality, balance, conflict, choice, destiny, love, loss, light and shadow, conscious and subconscious. Poets would possess an incredibly rich vocabulary of celestial imagery, comparing lovers to the moons, sometimes distant, sometimes close, sometimes eclipsing each other in a dance of passion and separation. Epic poems would detail the great conjunctions or lunar dances, weaving human drama with cosmic events. Listen to a lullaby about the chasing moons or the sleeping moon and the waking moon, shaping children's understanding of the world from their earliest moments. Narrative structures might frequently feature twin protagonists, parallel plots, or quests driven by the alignment of the moons, where prophecies are tied to specific lunar configurations, making fate itself a bi-lunar dance. The concept of fated pairs, or cosmic balance, would be deeply woven into storytelling, reflecting the constant celestial reminder of interconnectedness. Thus, the dual presence in the heavens transcended mere observation or artistic inspiration. It permeated the deepest layers of human identity and philosophical thought, shaping how societies understood themselves and their place in a profoundly interconnected cosmos. Duality would not just be a concept, it would be an observed reality ingrained into the collective consciousness. Philosophical schools might emerge, some viewing the moons as eternally balanced, a cosmic harmony reflecting the inherent order of the universe, while others might see them as perpetually striving, a source of dynamic tension and change, embodying the ceaseless struggle of existence. Ethical dilemmas might frequently be framed as choosing between the path of major and the path of minor, or finding equilibrium between two competing virtues, reflecting the need to navigate conflicting influences. The very self-perception of humanity would be shaped by this celestial configuration. Does having two moons make Earth feel more special or more complex? Perhaps the constant reminder of intricate celestial mechanics would make people feel more connected to the universe's grand, intricate workings, fostering an early understanding of cosmic interconnectedness. This might instill a profound sense of both humility, recognizing humanity's place within a vast, dynamic system, and grandeur, appreciating the unique magnificence of their double-lit celestial home. The language itself would evolve to reflect this reality, with new words and phrases describing dual phenomena, complex alignments, or the psychological states evoked by the two moons. Concepts like bilunar thought, double-mindedness, or being moonstruck in twain might become common expressions, reflecting a culture that perceives the world through a lens of inherent duality. The idea of solitude or singularity might be very different, or even alien, to a people whose nights are always shared with two companions. This shared experience of a double moon sky would be a powerful unifying force, yet also a source of subtle differences between cultures that interpret the celestial dance in distinct ways, ultimately fostering a unique sense of identity for Earth dwellers compared to hypothetical single moon or no moon worlds. We have journeyed through a world shaped by a celestial duality, a reality where two moons, Luna Major and Luna Minor, painted the night sky with an ever-changing ballet of light and shadow. We imagined a world of chaotic tides, accelerated planetary spin, and life forms hardened by relentless environmental pressures. We explored cultures steeped in twin mythologies, sciences driven by intricate celestial mechanics, and an art that celebrated the dual nature of existence. But now, let us gently withdraw from that vivid thought experiment and return to the quiet, familiar embrace of our own sky, reflecting on the profound uniqueness of a world graced by a single, solitary moon. Consider the simple, predictable rhythm that governs our nights. After conjuring up images of two moons, each tracing its own path, sometimes converging, sometimes diverging, casting complex shifting shadows, the singular presence of our moon feels almost like a profound silence. Our night sky offers a clarity, a singular focus that the imagined dual moon world could never provide. There are no competing lights, no intricate gravitational tug of war for our attention, only one serene orb, faithfully waxing and waning through its familiar 29.5-day cycle. This constancy is not merely an aesthetic preference. It is a fundamental difference that has rippled through every aspect of Earth's existence. Imagine the sheer relief of a predictable ocean. In a two-moon world, tides would be a bewildering, often perilous dance of surges and retreats, with superspring and super neap tides reaching unimaginable extremes, capable of tearing apart coastlines and confounding any attempt at seafaring regularity. Here, on our Earth, the single gravitational pull of our moon, combined with the sun's influence, orchestrates a remarkably consistent rhythm. High tides and low tides arrive with comforting regularity, typically twice a day in most places. This predictability allows coastal ecosystems to flourish in a stable intertidal zone, the area between high and low tide marks, where organisms can adapt to a consistent pattern of immersion and exposure. Without this regularity, many of the life forms we know might never have evolved, or would have taken dramatically different paths. The very shape of our coastlines, the distribution of marine life, and even the pace of our planet's rotation are intrinsically linked to this single lunar influence. Our moon, while gradually slowing Earth's spin over billions of years through tidal friction, does so with a steady, measurable hand. This consistent deceleration has contributed to a relatively stable geological history, without the additional, unpredictable stresses that a second, potentially more erratic, celestial body might have introduced. The long-term stability offered by a single lunar companion has provided a consistent canvas upon which the intricate tapestry of life could slowly, steadily, and diversely unfold. This stability extends to the very cradle of life. For early organisms, particularly those in the crucial intertidal zones where the land meets the sea, the predictable ebb and flow of tides provided a regular cycle of nutrient delivery and exposure to sunlight. Organisms could evolve robust strategies for coping with desiccation or immersion, knowing that the conditions would reliably return. In a dual moon world, with its chaotic, often extreme tidal fluctuations, the selective pressures would have been far more intense, potentially leading to species that were either incredibly robust and tenacious, or extremely specialized to very narrow, sheltered niches. Our single moon, in its quiet consistency, fostered a broader spectrum of adaptability, allowing for the rich biodiversity that defines our planet today. Beyond the physical realm, the solitary moon has profoundly shaped the human spirit and culture. Where a dual moon sky might have inspired mythologies of twin deities, cosmic struggles, or inherent duality, our single moon has often been revered as a singular entity. Across countless cultures, it has embodied concepts of mystery, femininity, regeneration, and constancy. Lunar goddesses like Selene or lunar gods like Sin, are often singular, powerful figures, their cycles mirroring the rhythms of life, death, and rebirth. This singular focus might have imbued early human societies with a sense of unity, a concept of a single guiding force in the night sky, rather than the complex interplay of two. The consistent phases of our moon provided humanity with one of its earliest and most reliable calendars, long before sophisticated solar observations. The lunar month, approximately 29.5 days, offered a natural division of time, crucial for tracking agricultural cycles, hunting patterns, and seasonal migrations. Imagine the challenge of creating a calendar in a dual moon world, where two independent cycles would need to be reconciled, perhaps leading to a more complex, less intuitive understanding of time for early civilizations. Our single moon offered a clear, unambiguous celestial clock, simplifying early human attempts to organize their lives and understand their place in the universe. In the realm of science and discovery, our solitary moon presented a monumental, yet ultimately solvable, challenge. Early astronomers, even without advanced instruments, could accurately track its predictable movements, leading to the development of early predictive models and the understanding of celestial mechanics. The simplicity of a single orbiting body allowed for clearer observations of phenomena like eclipses, fostering a deeper understanding of the relationships between Earth, Moon, and Sun. While a dual moon system would certainly have spurred advanced mathematics and observational techniques, as we imagined, it might also have presented such a daunting complexity that fundamental insights into gravity and planetary motion could have been delayed or developed along entirely different theoretical paths. Art, poetry, and literature on our Earth are saturated with the singular image of the moon. It is a symbol of romance, solitude, dreams, and distant longing. Poets have waxed lyrical about its silver glow. Artists have painted its serene face, and composers have written melodies inspired by its quiet majesty. There is a unity in its symbolism, a universal resonance that might have been fragmented or complicated by the presence of a second competing orb. Our moon's singular beauty has fostered a collective aesthetic, a shared point of celestial reference that binds us across cultures and generations, inspiring a particular kind of wonder that is both intimate and cosmic. Ultimately, the thought experiment of a two-moon Earth brings us back to a profound appreciation for the subtle, yet enormous implications of our own reality. One seemingly minor difference in the initial conditions of our solar system, the presence of a single rather than a dual lunar companion, has cascaded through every layer of our planet's existence. It has rewritten the physical laws governing our oceans and land masses, sculpted the evolutionary paths of life, and profoundly shaped the cultural, spiritual, and intellectual development of humanity. Our solitary moon, a silent witness to billions of years of Earth's history, has not just illuminated our nights, it has illuminated our very being. It has provided the stable rhythms upon which life could thrive, the predictable patterns that enabled early civilizations to flourish, and the singular, awe-inspiring presence that has consistently drawn our gaze skyward. It is the celestial body that inspired humanity's first dreams of leaving Earth, the destination for our most ambitious voyages beyond our home planet, and a constant reminder of the delicate balance and unique conditions that allowed our world and our species to become what it is today. In the end, our single moon is more than just a satellite. It is an integral part of who we are. It has shaped our sense of time, our myths, our art, and our science. It has fostered a particular kind of wonder, a focused aspiration, and perhaps even a sense of singular destiny. The echo of that imagined dual moon sky serves only to underscore the extraordinary, often overlooked uniqueness of our own familiar solitary companion, and the irreplaceable role it plays in the grand unfolding story of Earth.